Today in this video I am going to discuss different operations on sets. So first let's talk about the first operation on two sets, which is union of two sets. So we are going to discuss union of two sets. So the union of two sets, union of two sets is the set which contains all the elements of the two sets, whether common and whether common or uncommon. So suppose A is a set of the elements 1, 2, 3, 4, 5, 6 and B is the element 2, 4, 6, 8. So the union of two sets, which is denoted by the symbol U, A union B, is the set which contains all the elements of these two sets, whether the elements are common between them or uncommon. So 1, 2, 3, 4, 5, 6, 2, 4, 6, 8. All the elements of both of them, provided no element should be repeated. For example, if 2 is common between these two sets, so 2 is written only once, not twice. So 1, 2, 3, 4, 5, 6, 8. As you see, this set has all the elements of set A and set B. Some of the elements are uncommon, like 1, 3, 5, which are in A, not in B, and 1 is 8 in B, which is not in A, and some of the elements are common between them, 2, 4 and 6. So all the elements are included in the union of the two sets, provided no element should be repeated. Now, for better understanding, let's draw Venn diagram for this operation. Venn diagram is a diagram which represents an operation between sets. We usually make a rectangle which shows a universal set. So in the corner we write capital U or psi, and we write two sets intersecting two circles. First circle denotes A and the other one denotes B. So as you see in this Venn diagram, this portion of A, which is uncommon, and this portion of B is also uncommon, and this portion between them is common. So the whole space, common or uncommon, should be included to represent the operation union. So we have taken common and uncommon portion. So this is the diagrammatical representation of A union B. Now the second operation of two sets, which is intersection of two sets. So let us define first intersection of two sets A and B, which is denoted by a inverted U. It is called intersection. This symbol indicates intersection. So A intersection B is the set which contains only those elements of A and B which are common between them, Intersection of two sets A and B, which is denoted by A inverted U B, which is read as A intersection B, is the set which contains only those elements of A and B which are common between them. For example, A is the set 1, 2, 3, 4, 5, 6, and B is the set 2, 4, 6, 8, as we have taken in the case of union of two sets. The same examples we have taken here. So if we take intersection, so as we said, we take only the common elements between the two sets in the case of intersection. So 2 is common, we write 2, and 4 common, 6 is common, and nothing else. So we exclude all the uncommon elements between A and B, but we take only the common elements. So there are only 3 elements which are common between A and B, 2, 4, 6. So A intersection B is the set of 2, 4, 6. Now let us represent in a Venn diagram. So as we have taken rectangle, this is universal set, 2 intersecting circles showing sets A and B. So we take only the common portion between them in the case of intersection. So this is the diagrammatical representation of A intersection B. Now suppose there are two sets which have no element in common. Say the set A is the set of 1, 2, 3, 4, 5, and B is the set of 6, 7, 8. So you see there is no common between them. So in this case, if we write A intersection B, no element may be taken because no element is common between them. So in this case, A intersection B is written as phi, that is null set. So if two sets have no element in common, their intersection is phi. Now let's talk about the third operation, that is difference of two sets. So let us define it first. The difference of two sets A and B, which is generally denoted by A minus B, is the set which contains all those elements of A which are not in B. That means we have to take only those elements of A which are not contained by B. So let's take an example that A is the set of 1, 2, 3, 4, 5, 6 and B is a set of 2, 4, 6, 8 and we have to find A minus B. So A minus B is the set which contains all the elements of A which are not contained in B. So we have to take elements of A, checking whether it is included in B or not. If it is included in B, that is excluded, and if it is not in B, that is included in this set. So 1 is not in B. 1 is the element of A which is not in B, that should be included in A minus B. 2 is common between A and B, so we have to exclude it. Now 3 is not in B, so we have to include 3. 5 is not in B, so we have to take 5. 6 is common, so we have to exclude 6. So this is A minus B. Suppose now we have to find B minus A, so we have to check those elements of B which are not contained by A. So first element is 2 which is contained by A, so we have to exclude it. 4 is there in A, so we have to exclude it. 6 is also contained by A, so we have to exclude it as well. There is only one element, that is 8 in B, which is not contained in A, so we have to include only one element, 8. So this is B minus A. Now let's take a Venn diagram for better understanding. So rectangle which shows a universal set psi, and we take two circles representing set A and set B. So the portion of A which is not included in B, this is the portion of A which is not included in B, so we have to shade it, and this shaded portion represents the operation A minus B, the set A minus B which contains all the elements of A which is not in B. Now suppose we have to take B minus A, so we have to shade only that portion of B which is not contained in A. So this green portion shows the operation B minus A. Now let's talk about the fourth operation of two sets, complement of a set. By mistake I have written two sets. This is complement of a set. So complement of a set A which is denoted by A dash or A raised to the power C is the set which contains every element of universal set which are not in A. So let's take a Venn diagram. So rectangle shows universal set psi, and we take one circle denoting the set A. So we shade the whole universal set excluding the set A itself. So this portion outside A we have to shade. Shade the whole universal set leaving the set A. So this shaded portion shows that set which contains every element of universal set which is not contained by A, that is complement of a set A which is denoted by A dash. So the shaded portion shows A dash. Or in other words, we can say that A dash is equal to U minus A. That means the difference of universal set and A. This. Now let's take an example. That A is the set of 1, 2, 3. B is the set of 2, 4, 6. C is the set of 3, 6, 9, and universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now suppose we have to take the complement of A, so we have to take all the elements of universal set which are not contained by A. So 1, 2, 3, there are 3 elements of universal set which are contained by A, so we have to exclude these 3 elements from A dash and the rest of the elements are included. So 4, 5, 6, 7, 8 and 9. Similarly, complement of B, we exclude 4, 5, 2, 4, 6. So 1 we have to take, 2 is there, we have to exclude it. We have taken 3, we have to exclude 4, we have to take 5, we have to exclude 6, and then 7, 8, 9 which are not in B. Similarly, C dash is the set which contains all the elements of universal set which are not contained by C. So there are 3 elements, 3, 6, 9. So we have to exclude these 3 elements from universal set and rest of the elements are included in C dash. So 1, 2, 4, 5, 7, 8 and 9 should be excluded because this is contained by C. So this is complement of C.